Today we're going to start a short unit on probability. So as we get started, let's talk about what probability is. Okay, the probability is of an event is how likely something is to happen. The outcome of an event is the result of an action. So keep that in mind and think about a number line. And if the probability of an event, if we know that it absolutely is not going to happen, then we say the probability of that event is zero. It has a 0% chance of happening. It is impossible. On the other end of that spectrum, if we're absolutely certain, then we say that it has a 100% chance of happening. And of course, in the middle is if it's equally likely to happen or unlikely to happen, then it's a 50% chance. But the main thing that I want you to get out of this picture is that whenever you're asked a question about probability, your answer should always be between 0 and 1. There's never a probability that is larger than 1 or less than 0. Never negative. Okay? So let's look at one type of probability is theoretical. Theoretical probability is based on what should or could happen. For example, if you flip a coin 10 times, it should land on heads 5 times and tails 2 times. Excuse me, heads 5 times and tails 5 times. I was thinking about one toss. Anyway, so we define theoretical probability as the number of favorable outcomes over the total number of possible outcomes. So when you go back to flipping the coin, okay, if I said what's the probability of getting heads, then you would have one side is heads out of a possible two heads or tails, so it would be 1 out of 2. Let's talk about rolling a die. If you have a six-sided die, what is the theoretical probability of landing on a 4? So on a six-sided die, you have the numbers 1 through 6. How many of them are 4 is 1, and how many different options is 6? So it would be 1 out of 6. What is the probability of landing on an even number? So hopefully you know an even number is anything that ends in 2, 4, 6, 8, or 0. And on a six-sided die, there are 3 of those. So we have the number of favorable outcomes is 3. The total number is 6, and 3 out of 6 reduces to 1/2. So you would always reduce any probability that you have. Okay, so some more examples. Suppose you spin the spinner. What's the theoretical probability of it landing on blue? Okay. How many blue sections do we have? We have 1. How many total possible sections? 1, 2, 3, 4, 5. So the theoretical probability of it landing on blue is going to be 1 out of 5 or 20%. You can always give your answer whichever way is easiest for you. Okay, another example. What's the probability of landing on yellow or green? So you look at the spinner. How many sections are yellow or green? There are 2 of those out of a total of 5, so it would be 2 out of 5 or 40%. Now, away from the spinner, back to a die. If you roll a die, what is the probability of not rolling a 6? How many numbers on the die are not 6? There are 5 of them out of a total of 6. So the probability is going to be 5 out of 6. Okay, so the next type of probability that we have is called experimental probability, and that's the probability of what has already taken place, basically in an experiment. So if you flip a coin 10 times and it lands on 3 heads, the experimental probability of landing on heads is 3 out of 10. So you got to pay attention to the question. And our definition of experimental probability is the number of times an event occurs over the total number of possible outcomes. So let's look at some examples. If you roll a six-sided die 10 times, here are the results. We got a 1 twice, we never got a 2, we got a 3 once, we got a 4 twice, a 5 twice, and a 6 3 times. So you can see that all of these numbers add up to 10. What is the experimental probability of each? That means you're going to an experiment that you just completed to figure out the answer. So how many times did we get a 4? We got a 4 2 times out of a total of 10 times, which reduces to 1/5. All right, how about the probability of 2? How many 2's did we get? We got 0 2's out of 10, so it's 0 out of 10, but we wouldn't leave it like that. We would simplify it to 0. And if we said the probability of a 3 or a 4, then you're going to go to the 3 and the 4 and you would combine those. So that's a total of 3 out of the 10 that you have. So your answer would be 3/10. Okay, let's look at another example. You cut out the letters of Spain, Park, Jags, and place them in a box. You draw a letter at random, find the theoretical probability of the following. So it's not an experiment. We just need to look and see how many S's do we have. We have one, two S's, so two is going to go on top. And how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to have 2 out of 13. Doesn't reduce, so we're good to go. How many P's do we have? 1, 2, again, 2 out of 13. How many A's? 1, 2, 3 out of 13. How many R's? I have 1 out of 13. The probability of a vowel. So hopefully you remember your vowels are A, E, I, O, and U. We have 1, 2, 3, 4 vowels out of 13. And an R or an N, so you would go count up all of the R's and N's, and again we only have 2 out of 13. Okay, one last example. You flip a coin 20 times, your results are below, find the experimental probability. So this is coming from the experiment. Here are my results right here. So the probability of heads is that I have 8 heads out of 20. So it's 8 out of 20, which reduces to 2 out of 5, 2 over 5. Probability of tails is going to be 12 out of 20, reduces to 3 out of 5. What's the probability of heads or tails? Well, that's all I'm going to get, which is again 12 plus 8, which is 20 over 20, or 1. Go back and calculate the percent of each one so you can keep that refreshed and know how to answer the question. 2/5 becomes 40%, 3/5 becomes 60%, and 1 becomes 100%. So what I want you to do at the bottom of this is give me the percent that you think you will get on your test on probability after the Thanksgiving break. Let me know if you have any questions.